and Ana Rios at the Inter-American Development Bank. And these two papers focus on the poverty impacts, but more than the actual results, hopefully one of the take-homes from this presentation will be how we can think about setting up our simulations to capture climate volatility and just be aware of what it actually is that we're simulating, so that we don't simulate one thing and then claim that it's examining something else. So hopefully just try to understand what the implications of our approach are. So just in general, extreme climate events, there's a literature out there which finds that extreme climate events are going to reduce agricultural output in the tropics and the subtropics. And as far as the poverty literature goes, it's focused a lot on the poverty, the food insecurity dimension of this. So focusing on the supply side, the supply story in food security. But we know that food insecurity isn't just a function of people's access to, of just the supply of food, but rather the people's access to food. So this is where things like their incomes and the price effects come into play. So we know from the recent food price crisis in 2005-2008 that the price effects can be quite substantial, and Maro Shivanik in the room next door, along with our colleague Will Martin, found that about 100 million people were impoverished during the food price crisis due to these high spikes in food. So to start to understand these extreme, the impacts of extreme climate on agricultural variability, we need an intuitive framework. So this is where I'll be heading with the first paper. So what I did was I took FAOstat production data for Tanzania for 1971 to 2001, and then I estimated on the detrended production data the interannual changes in production. So once we've taken away the time trend and we look at just the interannual changes in production, then we can we can assume in a very stylized way that those interannual changes in production represent the impact of idiosyncratic shock. So you can think of it this way. Normally a farmer has a general idea of what the climate is going to be in their planting season, when it's time to harvest, etc. And so they make their optimal decisions based on those assumptions. But when the time comes, there might be a policy distortion, an unforeseen policy distortion, or some unforeseen weather, and that would be one reason why there might be a deviation from the previous year's production. And so I plotted. So if we think of that distribution as having a normal distribution format, then this is what we get for Tanzania. And unfortunately, the figure didn't come out quite the way I have it here. So essentially here I have the production distribution, and then I did the same treatment for the price of grains in Tanzania. And what we see is that prices tend to be more volatile than the interannual changes in prices. So once again, when we think about extreme climate events, they're going to reflect on this distribution of production shocks. And in a very stylized way, you can think of the once in 30-year, once in 40-year climate extreme as being a draw from the tail of this distribution. Okay? Yeah, so the once in 30-year draw, once in 30-year climate shock would reflect as a once in 30-year productivity shock draw from that end of the distribution. And so we were interested in understanding the sensitivity of various countries to this once in 30-year shock. And so I went ahead and estimated similar distributions for 15 other countries, and then from their distribution found what the corresponding interannual change in grains production would be for those 16 countries from those distributions. And then we applied them, we simulated them one by one in a comparative static CGE framework. So very briefly, the model that we used was the GTAP global CGE model, with some modifications. We introduced disaggregated land. So we disaggregated land by agroecological zone. We introduced factor market segmentation so that resources specific to agriculture can't migrate out into services or manufacturing. And then, since we're interested in poverty specifically, we introduced a micro-simulation module that's built on survey data for each of those 16 countries. So in the micro-simulation module, we estimated what the poverty headcount was for 7 representative household types, with each household type being characterized by their primary sources of income. Okay, so an agricultural household that you'll see is categorized as agricultural derives 90% or more of its income from crop agriculture, from livestock. Similarly, a household that's characterized as urban labor is going to derive more than 90% of its income from as wage laborers in an urban setting. And of course, this is going to capture the heterogeneous impact of the climate shock on grains production in those economies. So, for example, once we introduce the negative production shock, we're going to see an increase in prices, and that price increase is going to affect each of these households differently. In households that rely on the crop production, on the crops for their income, there's going to be a small positive effect. Their incomes are going to increase. But for net consumers, they're going to experience a decrease in their welfare because their basket of goods are now more expensive. And we simulate these based on a 2001 benchmark economy so that we have comparability across the different countries. So just a few additional words about the simulation design. So we shock grains production in a comparative static framework. So we're looking at interannual production changes. We assume a short-run closure. So the only factor of production that's mobile across industry, is labor. So you can't have capital like tractors or whatnot migrating over into some other industry right away. There's no adjustment in capital or land. And as I just said, we're shocking one country at a time from a benchmark 2001 economy. So it's a sensitivity analysis. It's not a forecast. No surprise here. We see that poverty increases in almost every country, in every country we look at. The magnitude depends on the benchmark structure of the economy. So countries that have larger numbers of consumers, for example, like Bangladesh, where there's a large urban poor population, the impacts are higher than in other countries where the urban poor are fewer than, say, the rural poor. And the increase in poverty in the number of poor is represented by the crosshatch sections, whereas the red sections, and it's difficult to see here, the red sections are the different numbers of poor by household stratum type. This figure, so we know that poverty is going to increase in every country, but what this table tells us is the distributional impact. So going across the tops of the columns, we've got the 7 different household types characterized by their primary source of income. And going down the rows, we have the 16 different countries. And then this table gives us the percent change in the number of poor in those countries. And they're all positive with some minor exceptions. And so, poverty increases in every country. But what's striking here is that when we often talk about climate impacts on poverty, we think about the damage to agriculture and that affecting the poor. But because of the price effect, what we see is that on average, the impact on the urban poor can potentially be higher. The percent change in the number of urban poor is generally higher than the percent change in the increase in the number of rural poor. And once again, it goes back to this interaction of the income and price effects. All right, and that's one of the advantages of having a GE model where you can track through the different mechanisms that drive the results. So as I was saying, this was a very stylized approach. So when we started the research project that these papers spun out of, we didn't have a statistical model of crop response to climate, and we're still working on the process-based crop model. So it was a good way of wrapping our heads around what of how we can think about climate volatility and agricultural variability, and what it really means to think about, extreme outcomes from climate. So the next evolution of this was, of course, trying to come up with a structural relationship between climate variables and crop response. And in the previous presentation, I spoke about how we went about estimating for Tanzania the yield response of 3 major staples to temperature and precipitation. So I won't speak too much about that here. But then, so based on the predictions on the projected yield changes for the historical period and then the future period from our statistical model, we were able to generate the interannual changes in yield, and that's what we simulated in our comparative static CGE model. So what we did was we took the interannual production change that from our pooled responses, and then we simulated each one of those shocks one by one as a perturbation from the 2001 benchmark. Okay, so this was important because what we wanted was comparability across each and every one of those runs. So it's basically saying, okay, what if the impact of climate on maize in 2001 was compared to the impact of climate on yields in 2029. Okay, so we've got that comparability, and from that we can generate a distribution of we can generate the sensitivity of the economic variables to this distribution of interannual changes. And one thing to keep in mind is that since we're working with yields, we're not thinking about things like acreage expansion. So if we think about interannual production, the variance in interannual production being a function of the variance in the yields as well as a variance in, say, the area harvested or acreage or area planted, then an assumption that we apply here is that the interannual production variability is just a function of yield variability, and it's not a function of how much area you're able to harvest. Right. So based on those on the simulated distribution of poverty outcomes, similar to the way we generated distributions of interannual yield changes in the recent past and the near future, we generate a poverty change distribution. So once again, it's 2 box and whisker plots where we're looking at what the interannual change in poverty headcount might be under the 20th century and under the near future in the 21st century. And what we see is that the mass of potential poverty outcomes is shifting rightwards. Okay, so the box represents the interquartile range, so where about 75% of potential outcomes are likely to be. And we see that the median is shifting rightwards in the 21st century. The 21st century is the one on top. And we also see that the mass of outcomes is shifting rightwards. At the same time, we see that the extreme outcomes, so extreme changes in poverty, are also shifting outwards. Okay, so coming back to this idea of extreme outcomes potentially becoming more important than just changes in the mean. So the big take-homes from this are, once again, that agriculture can be a complicated but important driver of translating climate volatility into economic variability. And here we looked specifically at poverty, and we saw that we need to, a GE simulation framework allows us to analyze each one of those drivers, the income effects, the price effects, in general equilibrium. And that we also saw how a comparative static model, even though by simulating from the same benchmark databases, lets us capture the sensitivity of economic variables to shocks that might vary across time. And finding that the future impacts are most likely going to be complicated across countries and depend very much on the structures of those economies, as we saw in the case of the poverty outcomes in the 16 countries in our sample. And once again, sort of the point that I tried to make from the previous presentation is that there's a lot to be learned from historical volatility. When we take any of these results and present them to policymakers, it's very difficult to talk to policymakers about what will happen to their economy, to poverty in 50 years. Whereas if we can relate it back to historical volatility, or in the volatility in the last 30 years, it's much easier for them to understand the marginal impacts of specific shocks. And that's it.